All right.
Good afternoon. Buongiorno.
Hello.
How's life?
Life is good.
About to get better.
Yes.
Should
I love this
come up with an
environment.
intro song.
Yeah,
Should
that has to
invite-
be sung by everyone.
Yeah, part of the grant should go for an intro song about ChatDKG.
Have a choir just to come in and just do like a full-blown a cappella, 3-minute intro. That'd be cool.
It's the new version of Do You Got the DKG? Do you chat DKG?
There you go. Creative juices flowing.
Yeah, where's Amos
All
when you need it?
right.
Okay, hello everybody coming into the call. Thanks for joining us. We're a tiny bit late, but I guess it makes sense to wait for everybody for a tiny minute because attendees are also late. So again, thanks for joining. Today we'll be looking at a bunch of interesting things, and particularly how you can build essentially a semantic search interface application based on OriginTrail knowledge assets and Langchain. So that's going to be the practical part of the demo. We'll be talking about other things as well. We have a few community members who have expressed the interest to share their ideas on what they want to build within ChatDKG. If you have an idea and you didn't know you could speak about it in this call, well, now you know. So you can speak about it in the call. So yeah, just feel free to raise your hand at the right point in time if you'd like to share something. Well, I know we have 2 people sharing 2 projects today, about 5-10 minutes sort of presentations. You can also do that afterwards as well if you'd like to share. But yeah, we'll go to that once we start. I guess this is just warming up, so maybe we give another minute to everybody, which is just enough for me to grab a drink. I realize I don't have any beer. It's Friday, and I don't have beer at home. That would be cool next time when we have a Friday office hours.
Just
Bring your
like in
beers.
good old days when Guinness brought plenty of beers, and by the time we started the office hours, the AMA, he was already well prepped up.
Very excited, right?
Yeah.
Yeah. Okay. So what do you guys think? 8 minutes is enough.
Yeah.
I guess it's a good way to start. So, okay, I'll share my screen. I have a short intro for you today, as usual. So once again, welcome everybody. This is the 3rd open office hours of the OriginTrail ChatDKG initiative to build an open framework for trusted AI. We're going to talk about it in a bit to give you a bit more context what that means, especially if you're new. And today with us we also have, so with me, I have the pleasure to introduce several people. My co-founders Tomasz and Žiga, who are here on the call, and our recently basically upgraded developer for the lead developer for the OriginTrail DKG, Max Grow, calling in from, I suppose, somewhere in Italy at the moment. And we have the general manager of Trace Labs, Yuri Shkornik, joining us as well. So you might have seen him yesterday on, if you visited the Sustainable Medicine Partnership webinar, where he actually showcased what we're going to show you today as well again, with the companies like Google, British Standards Institution, and AstraZeneca. So basically the event today is in a way related to what happened yesterday, and you'll see that in a very tiny bit. So I guess to get started, we're just going to introduce the agenda, what's going to happen today. We're going to talk about the decentralized AI with OriginTrail Langchain, and essentially go through these couple of points. So there's 4 points for today. We'll give a short intro. We'll dive into the guts on how you can build with OriginTrail Langchain. You're going to have an opportunity to learn quite a bit. So Max and myself will present some ways how you can play with knowledge assets and Langchain, particularly vector similarity search. We'll show that live so you can see how it's done and actually how easily it's done. And then we're going to go into the presentations that I mentioned. So whoever wants to present their idea, either because they want feedback or because they would like to invite other people to build with them or whatever reason, I suppose all of that you can get on this call. So feel free to raise your hand. Finally, we'll have an open discussion as always. So whatever you feel like is a good thing for this call, just go ahead and shoot. So, all right. There's about a few slides that we want to start with for the intro. So I'm going to jump right into it. First of all, if you're here and you don't know much about OriginTrail, OriginTrail is about knowledge and actually about knowledge being a new asset class. So the way to get the value out of this knowledge is to actually seize it with OriginTrail. OriginTrail is a decentralized knowledge graph. It's a very specific, unique, decentralized technology, which combines powers of knowledge graphs and blockchains. And today we'll show how. Just giving you a very quick pointer here to look at knowledge as really a new type of an asset. And having that said, what we're here for today is also this concept of knowledge assets. So we'll go very briefly from a high level to explain what the knowledge assets are about, and essentially what are the key value propositions of knowledge assets. So what can you do with knowledge assets? You can essentially get the value proposition of ownership of your knowledge. You can create and own the knowledge you produce. And in that sense, that can be any type of content. It can be, if you're a company, it can be some knowledge that your company is creating. If you're an individual, it can be any type of content you're creating online that you essentially package into knowledge assets. Could be videos, could be things like your posts on social media. And when you do that, when you create this knowledge asset, you essentially also under the hood get an NFT that represents that knowledge asset. So you can see on this quick GIF, we'll show that in a bit as well. You actually create, rather mint an NFT that is uniquely connected to the knowledge that you're creating. With this NFT, you're able to basically not just claim ownership, you're able to essentially you tokenize your knowledge and you're able to benefit from this, the benefits of tokenization. You can, for example, expose your knowledge to various markets. Especially today, this principle of ownership, not just in Web3, but in the general compute space and AI space is becoming increasingly relevant. Obviously, you can see that by companies owning their own AI models, but not just the AI models. There's always this question about like, how did they even get access on, or who owns the data that was used to train the models? Who owns the weights of the models? Where are they? And so on. It's a pretty big topic, and essentially a core principle of OriginTrail and a core value proposition behind knowledge assets to provide ownership to knowledge to whoever has created it. Following up, once you own some knowledge, it doesn't really hold a lot of value if you don't make it discoverable. And what does discovering knowledge mean is essentially having an ability to find it, to search for it. Just as you use that, you use the search, for example, in classic Web 2, you're able to go to Google. Sometimes you might have heard of OriginTrail being like this nicknamed Google of Web 3. Well, essentially, it comes from this value proposition of discoverability. So knowledge assets have the properties of ownership and discoverability, because in this way, we're actually able to create this incredible decentralized knowledge graph. So one large graph that can connect all the knowledge, but people actually remain, people and companies, they remain owners of their knowledge. They're able to host it and keep that knowledge within themselves, rather than all of that being indexed in some proprietary database or one centralized place that actually gets to, in a way, gain ownership of that knowledge. And that has been happening all over Web 2. I'm pretty sure the audience on this call has a good idea about it. So, but the key value proposition here being discoverability is that the problem of retaining ownership, meaning retaining, let's say, hosting of your knowledge within some device or server somewhere, it kind of inherently makes it disconnected. That's why this centralized approach was, the key solution previously with companies that have been aggregating information across the entire internet, because they were able to centralize it and connect it and index it. I'm talking organizations like Google, Facebook, all of these big ones, which, by the way, all use knowledge graphs under the hood. And long story short, if you're able to actually decentralize this knowledge and keep it in different places, you have to have ways to make this knowledge discoverable. That's why this is a key value proposition for knowledge assets, essentially making this knowledge connected and enabling builders to find it. And we'll show that how in very, very soon. The third value proposition is verifiability, a really important value proposition. Because once you decentralize the ownership of knowledge and once you make it discoverable, then it is really important that when you find something, you actually know where it comes from, who was the issuer, what happened with that knowledge, how was it changing over time. Rather, you would ideally know the origin of certain knowledge and the update trail of all of that, the states that knowledge has gone through. And these are just some components of verifiability. Verifiability is a pretty big topic, but essentially with some key primitives like such as being able to understand that certain knowledge indeed comes from a certain entity, like be that a person or a university or whoever, having this key value proposition be part of verifiability. This key tool of verifying the identity of the issuer, verifying the update trail, and then certain other things, for example, such as verifying that a certain statement is part of a certain knowledge asset. This is also a very, very important value proposition needed in order to make a useful decentralized knowledge graph. Finally, with such verifiability properties and with all of the previously mentioned value propositions, we are also, in a way, with knowledge assets get to this property of AI readiness, and we'll showcase this today. AI readiness meaning having an ease of use of such decentralized knowledge assets within AI systems. So ease of use meaning many different things, such as, for example, that knowledge assets already contain certain semantics within them. This semantics is very useful because that can be understood by large language models, for example. Also, the abilities to leverage the semantics to even further upgrade this knowledge. This is something we briefly touched upon previously, but that's a whole interesting topic of graph machine learning and essentially knowledge graph embedding. Basically, one of the things you can do in such ways is when you have knowledge about certain entities, you can predict the links between these entities, and this is called like a link prediction task, which is really cool because that, for example, enables recommendation systems and so on. All of this used relatively widely in the biggest companies in Web 2. The idea with OriginTrail obviously being open source and decentralized to enable this for entire Web 3. So this is briefly about knowledge assets. Knowledge assets, like I said, are ownable, discoverable, verifiable, and AI ready. And with that, why are we here today is to create a framework. When I say today, I mean generally, not just today. We're actually creating a ChatDKG, DKG standing for Decentralized Knowledge Graph, a framework with which you can leverage trusted knowledge from the decentralized knowledge graph, knowledge assets, for efficient search, accessing, utilization with AI. So the idea of this framework that we're here to build together is essentially to achieve the following objectives: to create technical tools based on knowledge assets and AI, to establish best practices for discovering, accessing, querying, and verifying trusted knowledge with AI tools, adding AI tools, and without also on top of that, on basically creating tools and using the knowledge, is also how do we generate or populate a trusted open knowledge base by creating knowledge assets through crowdsourcing. So essentially populating the OriginTrail DKG mainnet with a lot of trusted knowledge through this project. There's 4 key areas that the ChatDKG framework focuses on. First one being semantic search over knowledge assets. For example, one such an application will be knowledge asset vector similarity search, which we will showcase today. We talked about this demo previously on the previous calls, but we only showcased the diagram. Today we'll actually show you how it works and how it can be built. So this is one of the areas, and this is one example that we will show. But there will be under this area, there's obviously much more that can be done. Semantic search is a pretty wide field, and especially in this synergy between knowledge graphs and language models, that there's a lot that can be done in the area of semantic search. Second group is natural language querying over DKG. So think of it more of a slightly different task than search, rather producing a very eloquent, if I may say, query, graph query, for example, Sparkle query that would be inferred from a natural language question, so that you can actually do graph querying through some form of an NLP AI-based interface. Also pretty wide topic, there's a lot of research going on in this area, a lot of models being trained over it. So yeah, we're looking forward to seeing who's excited in building in this area. From what I understand, there's already a few people that are looking into this in the ChatDKG developer group. Third area is AI-based knowledge publishing tools. So the idea here being that on flip side from querying is how do we create the best knowledge? How do we prepare this knowledge so that the queries can be richer, more effective, more precise, more powerful, right? An idea, an example here would be creating agents for semantic enrichment of knowledge assets. Think of having a knowledge asset, some corpus of knowledge, which you can let an agent enrich further by finding relevant information previously disconnected but available somewhere online and connecting it with this knowledge asset. So that could be information sourced from places like Wikipedia, Wikidata, other knowledge graphs like DBpedia, things like, just as an example. I'm sure people can have even better ideas than that. It's just like the first, I guess, most simplest example of this approach. Finally, the fourth area is general AI system integration. So if there are cool ideas that are useful for integrating knowledge assets with certain systems, such as Google Bard, Hugging Face, that don't kind of really fit the first three, then obviously that's also very interesting. So if you have any general ideas like that, it's also possible to be part of the framework. The criteria for building is that if you're building, you need to build something that's public and open source. So unfortunately, like funding through a grant program, and by the way, there's a grant program, if I didn't say that precisely, behind ChatDKG. So funding something that's proprietary and closed source doesn't really make sense. So as the first criteria, the second criteria is obviously has to apply to knowledge assets. The third is that it has to solve a meaningful problem. So meaningful is, I guess it's a wide term, but generally, if you're not sure about what that means, you can think about it in terms of applicability. So is it narrowly or widely applicable? Is it only for a small group of people or a lot of people can use it? How big the problem is, and so on. And finally, one of the criteria is that we do building of all of this together. So it's not about, some lone developer sitting somewhere in a dark room and not interacting with the rest of the community. The idea is that, we're all learning here and we're building together. So Likely you're learning as well. You're probably not a 20-year-old seasoned AI veteran plus blockchain veteran plus knowledge graph veteran. Likely, if you know something, you're probably good at one or maybe two out of these three things. And so the point here being is that this is an ideal opportunity to share and learn together. So if we are active together, engaged in the Discord channel where we basically all meet together and share ideas and ask tough questions if needed, that's going to be beneficial for everybody. So these are the 4 criteria and the general areas about ChatDKG. Like I said, there's also a grant program. We'll go to that at the end of this call, but essentially the grant program offers 1 million track tokens as a budget. It goes on an ongoing basis. And if you want to find out more, you can also go to chatdkg.ai. Everything is basically pretty self-explanatory there. Okay, so having that said, we're actually going to go into this second part of the agenda where we go now deeper into how you can build semantic search applications, trusted semantic search applications based on OriginTrail and Langchain. However, before we jump into the code, I'm just going to explain a couple of concepts. And actually, before the concepts, it's probably even better to show the demo. So I'll show the demo immediately. You guys should still see my screen, right?
Yes.
Thank you. That was very kind of you, sir. So what I'm sharing is a demonstration interface. If you were yesterday at the call for the Sustainable Medicine Partnership, you've seen Yuri present it. And if you were not, I'll just try to explain it very quickly today. This is, like I said, a demonstration interface where we'll see how this can be applied on knowledge assets. So the idea here is that we have created a knowledge asset that represents a medicine. It's an invented medicine. It's not real, it's fake. It's called YewMaker. The reason why it's called YewMaker is because YewMaker is our partner from the Sustainable Medicine Partnership. And essentially the idea of the demo is that you can actually chat in a way with your medicine. So specifically with the leaflet of the medicine. You know that thing when you open up the box and inside of the box of the medicine, there's this paper that explains, I don't know, how you can take the medicines, how many pills a day, what to do if you're pregnant, things like that. So basically, we created a knowledge asset out of that. And with that, you can now actually ask questions to this leaflet. So for example, I can ask, what are the side effects of YewMaker? I probably could have said just what are side effects. And what I got here is actually the result of an extraction process. Up here, you can see there's 2 options. There's the extract option and there's extract and summarize. The extract option, meaning there's no AI crunching this information. Rather, there's only a semantic search process happening. So what you're seeing here is actually more like Google search result rather than ChatGPT, even though it might look more like ChatGPT. The idea here is that we perform extractive semantic search. So we asked the question, the system understood the question and said, okay, this is semantically the closest thing to what you asked for. And then this is the next one and so on. So the semantically closest thing, as you can see, it pretty much found it pretty well, is this particular section. There's no edits. It's completely like copy pasted from the actual what is it called? The leaflet, right? I get lost. So the point here being is I can also ask it something else. I can ask, can I take this medicine if I am pregnant? I suppose should find that as well. What you need to know, pregnancy and breastfeeding. Basically, it finds the right thing. It actually does that pretty fast, and we'll explain how to do that. So like I said, this is extractive question answering. There's no changes whatsoever. And that's actually pretty cool, especially for enterprises, for one particular reason, which is if you're about to use a generative AI system, you also immediately come into the risk of having the generative system potentially hallucinate. And this hallucination being essentially very critical if you ask a question of such as, can I take this medicine if I'm pregnant? If that's medicine, if you ask this to ChatGPT, and I'm sure pretty much all of you have ran into some weird answers, at least weird. I've also found some completely wrong answers from ChatGPT. It's normal because it's a very general system, and it's also a generative system. It's a really good autocomplete if you want to sort of simplify it. And naturally, there's some significant probability, especially for enterprises, that is going to have a wrong answer. So the semantic search based on a trusted knowledge asset, which you can always see at the end of the answer, you always see the source of the knowledge asset, and we're going to actually open that now. Okay, that's behind. This interface hasn't launched just yet, so just give me a second.
I'll send you the credentials.
No, I have them in, but not here. So I have them in, I think, in a different browser. Should be saved. Yes, they're saved. So here you go. It's loading. So I'm basically, what I just did is I opened the source of this information. I went into what we call the DKG Explorer, which you guys can see here. And we're actually, right now, we're viewing this knowledge asset. The DKG Explorer interface is not live yet, but it's very soon to go live. And what you can see here is actually the profile of this knowledge asset. This is the actual graph, the knowledge graph of the knowledge asset, and it contains all of the information from the knowledge asset, in this case, the YewMaker tablets. You can see a bunch of things that are connected here, and this was produced from, like I said, from this leaflet. There's also, this is the symbol for the knowledge asset. There's also the UAL, which is basically the Uniform Asset Locator. You can see it here more clearly, which is a unique property of knowledge asset. It's essentially a composite identifier resource locator, essentially, which is composed of a blockchain DID and a knowledge graph identifier, potentially, knowledge graph state identifier. Without providing a state identifier, you can think of it as kind of a URL, and it basically returns the latest state of a knowledge asset. So in this case, you can see this is a decentralized identifier. It can be found on the DKG, the address of the smart contract where the knowledge asset lives, and this is particularly the token ID behind this knowledge asset. Which token ID? Well, we can actually open it here. This is the NFT token that represents the owner, the ownership of this NFT, of this knowledge asset. It's a classic ERC721 NFT, and you can see it here on the block explorer for OriginTrail parachain testnet in this case. So being a classic NFT, you can also include it in your wallet. You can send it to somebody else. You can trade it on a marketplace. And when you do that, you can actually observe the history of the knowledge asset, or rather knowledge asset status updates. So when we created it 2 days ago, it basically had a specific issuer and a state hash. Then just for demo purposes, we did an ownership change from one wallet to another. And then with this, now whoever is the owner of knowledge asset actually is able to modify the knowledge asset. So knowledge assets can be updated. For example, you can add additional elements into this graph. So the new owner of the knowledge asset was the one who updated. So we can see this, like I said, this information trail and the source of the information in each particular update. We can also see connected knowledge assets. For example, here we see another knowledge asset with a knowledge asset, which I'm going to click on, and it's going to be loading from the DKG testnet. It takes a moment now. Like I said, we're still optimizing this, but essentially what you can see now is this. Actually, this is the information about this is the so-called product master data of this particular medicine. This is just a case of medicine, but you can see that these are specific tablets. They have a specific unit code. Honestly, I suppose this is 25 grams. Yes, the code is gram and 25. This is the GTIN, basically the barcode behind it. There's some description, so on, and there's also another connected knowledge asset. Essentially, you can, using this DKG Explorer, you can explore the entirety of the graph connected with this knowledge assets. So the more I explore, the bigger it gets, right? And yeah, here we actually see that the company that makes this, the hypothetical YewMaker Limited that makes this this medicine. So the point here being is that very different types of knowledge can be connected in one connected set of knowledge that you can actually query. And that's what we're doing essentially with this interface. So back to here, when I ask a question, what are the side effects of YewMaker, it actually goes into that graph, does a few things such as semantic search, and it finds the best possible answer within the graph. It doesn't go outside of the graph. It doesn't like generate anything. It doesn't hallucinate. It just it's very contained to this verifiable knowledge that has a verifiable source. However, this is just one example. This, like, again, this is an example interface. This is not don't consider it as kind of a be-all end-all. It's because building on OriginTrail is building on a protocol that allows you to do different types of things. For example, we can also extend this with a generative model if we'd like to as developers. So we can change to this extracted summarize mode, and I can ask the same question. I'm just going to be lazy and copy it. Can I take this medicine if I'm pregnant? Actually, what's happening now under the hood, and again, this is a demo app, it extracts the same basically part of the graph from the knowledge asset, and then it submits that to ChatGPT in this particular case, to OpenAI API. It's a bit of a tongue breaker there. And basically, it summarized the same information here, which says that if you're pregnant, what you should do. Here it says it's recommended to talk to your doctor before taking if you're pregnant, and so on. So basically, you can also try the other one, alter the side effects. So essentially, we contained the space of information to which a generative model was instructed to just summarize what it actually saw. For example, that the side effects include swelling feet, ankles, and so on and so on. Always, though, keeping and showing the source knowledge, the URL and the owner of that knowledge as the important verifiability and basically trust root for this particular answer. So to conclude, what you're seeing is an example of an application that does semantic search or semantic search and summarization based on knowledge assets. And what we're going to go deeper a bit now into is how this works. How can you build this? It's actually not that hard. And before Max jumps into it, I just want to explain one more thing, because that might not be so obvious from knowledge assets. What are they made of? So back to the presentation. If you have been asking yourself, okay, knowledge asset, what does it contain? So the anatomy of knowledge asset is such that it lives on two layers. It lives on a blockchain, because this NFT and the other stuff I'll explain, and also lives in the decentralized knowledge graph, the OriginTrail decentralized knowledge graph. There's one decentralized knowledge graph connected to multiple blockchains, so it's actually possible to pick a different blockchain for creating your knowledge assets. The key component being this knowledge. The URL, as I mentioned, it is the identifier for the entire knowledge asset, or the uniform asset locator. It's like your Web3 version of URL. The knowledge state proofs, the proofs you have seen. So every time, for example, when you create a knowledge asset, your client that creates it, the application that creates, in order to create a valid knowledge asset, needs to submit a Merkle hash, a Merkle root hash of the graph of the knowledge to the blockchain. This is important for several reasons. One reason is to show, to always be able to verify that the knowledge that has been queried from the graph corresponds to exactly the same content that was published by whoever the publisher was. So hypothetically, if there was a man in the middle attack and somebody changes the knowledge, changes the information, you're always able to detect that and to actually query from another place. So that's one thing, but also it offers some other cool properties, such as providing inclusion proofs. Because a Merkle root is used, you can actually prove that a certain piece, like let's say a statement or a fact, is part of a knowledge asset without having to share maybe the entire knowledge asset with somebody else, because you can produce a Merkle proof that says that, aha, indeed, this was used to produce this hash. If you're not familiar with Merkle proofs, this is not the right time really to go deep into it, but like it's very interesting technology and not that complex, so I suggest take a look at it. Apart from state proofs, obviously, each transaction has an origin or an account, a wallet that has basically produced it, so we have this verifiable provenance of knowledge. And then finally, we have the knowledge NFT. So the knowledge NFT representing ownership, but also allowing, in a way, administrative control of the knowledge asset. You can update the knowledge in the knowledge asset with it. Finally, all knowledge assets are part of the DKG index. That's why you can find them in the DKG, and you can actually search for them. So if you wanted to create a knowledge asset, let's say using a JavaScript client, you basically instantiate the client in your code by calling the classic new DKG, and you can create them, you can get them by the UAL. Once you create them, you can update knowledge assets if you own the NFT. You can also transfer them. This is the classic ERC 721 transfer function. And you can also, for example, get the owner. If we were to go into kind of an example, I just showcased this last week in Copenhagen. So basically, think of the knowledge part being essentially a graph, somehow serialized. One way to serialize a graph is JSON LD, which is what you're seeing here. It's an extended version of JSON, or JSON for linked data. You have a UAL that has the structure of actually pointing to a particular chain and a contract and a token ID on that chain, which is where the record for the state proofs is kept. And the state proofs essentially, like I said, being Merkle root hashes. So when you know this UAL, you can basically go on the chain. You don't need any type of DNS or resolver. Your own system can go and figure out, without need to trust anybody, what's on behind that record, and it will get the latest hash, which allows it to query that particular knowledge asset state from the blockchain. That also means you can get previous states. You just need their hashes. It's literally the same as a GitHub or your Git repo commit commits on a branch. So you can go back to like a commit, 2 commits before, or a specific commit in the history. So this is an explanation of knowledge assets. And now I'd like to ask Max to share his screen to show us how, oh, actually I have one more slide to explain. But Max, get ready. I'm going to be quick. So essentially, we're going to show you how this is done. But what did we do? So we took all of this knowledge from the knowledge graph, and actually we created these graph embeddings, rather text embeddings in this case, sentence embeddings, where essentially out of the symbolic representation of knowledge, we also created this neural representation, these embeddings or vectors out of this information. And then we didn't perform exactly a machine learning task, but in a way, we essentially did semantic search on that. So when I typed in a question, what happened is the question was also vectorized. An embedding was created. Then the vector similarity search compares this vector distance in space. You can consider it as kind of like distance of meaning. And when it finds something that's close in meaning, then it basically it shows you, aha, these are the results I got, and I got it from this piece in the knowledge graph. It has this, essentially this source. It's not, invented out of nowhere or generated or something. So Max is going to take over and show this step by step whenever he's ready.
Thank you, Brana.
Thank you, Max.
Please let me know when you can see my screen.
Yes, we can see it.
Okay, so I will start from the leaflet. So this is the PDF file which we want to upload on the DKG. So we want to create an asset out of this. So you can see it's a standard leaflet. It has sections, some subsections, and what we did. So I will show you, I already prepared the dataset. So can you see the dataset?
Yes,
Okay.
very well.
Thank you. Okay, so this is a JSON-LD representation of the PDF that I just showed you. So it has some context, some URN as ID for the leaflet. It has a type. We added this property belongs to. So basically, it's connected to some other UAL. So once we create it, it will be connected actually to another knowledge asset. And then we divided it into sections and subsections. And I will explain why in a moment. So you can see we have a title for each section and then title for each subsection with the text that we had in a PDF. So the next step would be to actually create this knowledge asset on the DKG. So we will do this together now. I have created this in another file, but I will type it in so you can easily follow. Okay, so the first step is to import the DKG.js, and also we will import the FS module. And also we will read from the file that we created. So okay. And this is the file path. So YewMaker.json. Now what we do is as Brianna mentioned earlier, we just need to create the DKG client instance. We will need some options for this. So we'll need to specify the endpoint of the node that we will use to create the asset. And I have this in the .env file because I don't want to share it. And
yeah, maybe while you type it out, for those for folks who are not familiar with using decentralized networks, essentially you need some sort of gateway to access any decentralized network, and there's ways to do it. Either you run your own gateway, or in this case node, or you can connect to a node that somehow you got access to, somebody gave you access to, or whatever, or you purchased access to. In the blockchain world, this would be your RPC, Infura, QuickNode, whatever type of provider you use. In the DKG world, you essentially either run a node or get access from somebody who runs a node. In this case, Max already has a node which is at a certain URL. It provides an endpoint essentially at that URL. And apart from that, also obviously one of the things that is unique to the DKG, it's a multi-chain decentralized knowledge graph. So you have to decide, you have to basically specify a network that you will be using. And in this case, we're using the OriginTrail parachain testnet, and we're using a certain key, a wallet, essentially, with which we're going to be creating the knowledge assets, so that you can see this public and private key, which Max doesn't want to share because he doesn't want you to steal his tokens. Shame on you.
okay, so what I did here was to, as Brian said, I created the DKG instance. And now what we can do with this is to create the asset. So we got the JSON-LD file. This is the JSON object. And then in the options, we specified the number of epochs for which this asset will live. So when you create a knowledge asset on the DKG, it doesn't live forever. This is not a blockchain. So you will need to specify how long this data will live on the network, and based on this, you will also require more or less tokens depending on how much you want this data to live for. So let's see, we will console log the result. So this is its result, and then let's say we just want to console log the UAL. Okay, so I'm now running the script. It will take a while. So what it is doing now in the, oh, wow. Okay. This wallet is used also by the node. So basically the node was performing some transaction and it's trying to also create the asset. So we're having this error. So let's try again. Okay, this is not what we expected.
Yeah, so do you have another wallet?
I don't have another wallet. What I can do is just modify the gas prices in the.
Yeah, do it, hack it. So I can maybe explain why you hack it, what's going on. First of all, we're having a demo. So normally when you have a demo, you have some problem. But no, outside of the joke, what's happening, and it's reporting that the transaction is underpriced. The blockchain, there's already a transaction by this wallet that is being submitted to the blockchain. Like Max said, he's reusing a wallet from the node. And because the blockchain understands that there's another transaction coming in, it can actually get confused and understand, aha, there's two transactions, same price, with essentially the same properties, so it can complain, and even before it tries to submit the transaction, gives you back an error and says, hey, your transaction is underpriced, for example. In this case, it's probably not the most appropriate error, but it's we've seen it before. So it's something that let's say if you're sending some transactions in a scheduled way, and you're trying to squeeze in another one in between, that's something that can be a problem when you're using blockchain. This also comes from this property of requirement rather of blockchains needing sequential transaction. So each transaction that you're sending has to contain a certain nonce or ID, basically starting from 0. So you can think of it as kind of a transaction index, or if you have, I don't know, created 100 transactions before, the next nonce will be 100. So and the problem is if you send the same just two transactions, different transactions with the same nonce, only one will be included into the blockchain because that's another requirement by the blockchain, apart from a couple of other requirements. That also means that if you're using one wallet, you have to keep this in mind. Okay, it looks like it's moving now, right, Max?
Yeah, it's moving. So it's probably slow because we have this other transactions. So I increased the gas price, so it should be prioritized.
Okay. Can you explain a bit what's going on right now under the hood?
Yes. So how it works? This JSON-LD dataset is being converted into this format, which is called encodes. And we create, as Brana mentioned before, we create the root hash out of these encodes. And then there is a transaction on chain which is executed, which is responsible for creating the actual asset on chain. So it will take as inputs, for example, the size of the graph, so the number of triples. It will take as input also the root hash, so that we can later verify that the data hasn't been modified. And so this is why it's slow at the moment. It's creating the transaction on chain. Usually it doesn't take this long. I'm not sure what's going on, but what we can also do is go on with writing while we wait, and if it doesn't work, we have already a UAL which we prepared earlier, and then we can test it with that one. So okay, so just to show the next steps. So we wanted to also show that once the asset is created, we can query the network and execute a SPARQL query to retrieve some information about the dataset. So how we do this is we dkg.graph query, and then we type in the SPARQL query. I will copy paste it for the sake of time. I have it prepared somewhere else.
Can you briefly explain what the query does?
Of course. So this is a select query, and what we're trying to get is the type of the dataset. So this is how the namespace for the types in RDF. And what we're looking for is the object of the triple, which has subject leaflet, and this is the ID that we have specified in our dataset. And as predicates, it will have the type, and then we're looking for the object of this triple. So what we expect to get from the network is basically a digital document, because this is what we specified earlier in the dataset. So I will stop the creation of the asset as it's stuck, and just console log this query result.
Yeah, so for the folks who haven't had any experience with SPARQL before, this is basically a graph query language. It looks a lot like SQL, and it essentially enables you to find something called, via some pattern matching paradigm, you can match things. It's very similar to writing, let's say, select the value for type, where this column equals leaflet and the other column equals type. It has a little bit of a different syntax, but essentially it finds, this is just a kind of a simple example of how you can do a query. So it's basically the knowledge graph is your, let's say, graph database with superpowers, and you can do all kinds of very complex queries, but this is just a very simple one. So using this, we can verify that the data is already in. So either it was created now by this knowledge asset creation that somehow we didn't get the result back from, or because we created a previous one. So anyhow, I suggest we don't debug right now and figure out what happened wrong. I suppose the hack you tried didn't work, but we still have everything. We can move on with the demo. So I suggest you just keep going.
Yes, so you can see that the result is there. This is from the previously published UAL. So previously published knowledge asset. So this is the result. We have the type, and you can see this is correct. What we're going to do now is we're going to store this data that we created. We will store it in a vector database so that we can perform a similarity search, as Brianna mentioned before. So how to do this? We created a Python script, and I will copy paste it again for the sake of time, and I will explain everything that I did. So how this works? Basically, we will import Langchain, and this is the framework that we will use to upload the embeddings to the vector database. We also import pandas, which is just used for reading some file, and then we will load the data and store it in the DB. So this is very simple. And how it works, we created a file which is called output.tsv. This was generated previously. Again, we don't have the UAL now, so we'll just use this file. And I will explain how it works. So this file contains all the necessary information for the vector search. So we have some fields which are metadata for our text. And we have UAL, the resource ID, and this is totally arbitrary. You can put whatever you want. We decided to put obviously UAL because this is what we need for the verifiability and discoverability. We need the ID, section title, subsection title, and we need the body. So you can see from the data set that we created, we have multiple sections. Each has a title, subsections with their titles. So what we will do is we will store separately each body in the dataset so that we can perform similarity search, and the answer will be given based on these objects here. So let me see. So this is the Python script. Again, we will read from this file that we generated and upload to Milvus, which is a well-known vector DB. It has a collection name of Office Hours demo collection, and we will also use Hugging Face embeddings with this model. So maybe Brana, you can mention this, but you can explain more about this. But this is the model we chose to use because it's optimized for small sentences and small text. So it shouldn't exceed 500 words from what I know. And yeah, this gave us the best results.
Yeah, essentially we tested with a bunch of different models, but it's not to say that this is the best one for everything, but for this particular task, we just essentially iterated, I think, about 10 different ones, and ultimately found that this one provided the best MRR score. Not to go too deep into that, but essentially it's kind of the score for relevance of search results. You know how you go to Google and usually you get the best result always on top, but sometimes even Google, which runs for like, how many, 20 plus years, even Google doesn't always give you the best result in the number one spot, right? So, but like the higher the spot, the better the score, right? So this MRR essentially means that is how well the search ranking comes out. And in this particular case, we used this model because we found out on measurements we performed that it was performing the best. Are you having some trouble again?
Yeah. Let me see what it says.
You're sure you got the right?
Okay, yeah, I know what this is. I'm just missing the basically the code to get from the .env file the information. Langchain. So we missed the URI, user, and password for the Milvus connection.
Mm-hmm.
So now it should work.
Okay, it's moving. So maybe once again, because it might be a little hard to follow, it's essentially all of the vectorized content of the knowledge asset has been produced by this AI model, and it has been sent into the vector DB. So the vector DB helps us do similarity search. This is the actual vector DB from Milvus, or it's an open source vector DB. You can also try it on your own. They offer this free Zealous tier. And yeah, I guess Max, you're better to explain this.
Yeah, you can see that the collection was created and we have all the necessary information here. So we stored the body of each subsection inside the text field. And then we have some subsection title, which in this case is undefined because we didn't have it. But for example, here you can see we have do not take YewMaker and tell your doctor if, and this was the bolded part. So these are the titles of the subsections that we added. And then we have section title, ID of the resource. and also the UAL. So you can see that we created the collection, and now the only thing left is to connect to Milvus again. We have this search.py file. So we will basically do the same as before. We will connect to Milvus. Obviously, we want to use the same collection as we just created. We'll use the same model for the question. And we can define a question. So in this case, I define, can I take YewMaker role if I'm pregnant? And then we will perform similarity search from the vector.db. So this is like very simple. It's a few lines of code, and it will give us back a response. So in this case, the response is by default, it will give you the 4 most similar vectors to this question. So if you ask this question, it will be vectorized, it will perform similarity search, and it should find the 4 most similar, semantically more similar responses from the data that we uploaded. So what we do next, we just print, we create an object just to stringify it, and then we print it to the console. So I will just remove this part from now. And execute the search.py script. So as I said, it's connecting, it's asking the question, and this is the response that we got. So here we get back an array. This array contains 4 answers by default. And you can see we have page content, and this is the text of the subsection. And in the metadata, we have the URL, the ID, section title, and subsection title. So for example, the question now was, can I take YewMaker role if I'm pregnant? And you can see that the subject section title is pregnancy and breastfeeding, which seems very relevant. And this is the relevant section. And as Brana mentioned, we can, on top of this, make a call to the OpenAI API and summarize, ask it to provide an answer to the question based on the data that we extracted. So we first perform the similarity search as we just did. And then we ask ChatGPT to provide a response based on this data that we extracted. So this is the same, it's very simple. We just have to pass the Open API key. And then we specify the model, which in this case is GPT 3.5. And then what I did here is tell ChatGPT that how it should behave. So you receive a question and some JSON, and you answer the question based on the information found in the JSON. You do not mention the JSON in the response, but just produce an answer. So this is basically the instruction that I gave him. And then the next message is answer the question, and then we give him the question based on the following JSON. And it's simple enough. So if we run it again, you will now see that we have the same extracted data. And then here, I hope it's visible. Extracted and summarized response. We see here, if you're pregnant, it is recommended that you talk to your doctor before taking YewMaker role. And this is a nice summary of what we previously had. So, okay, Brana, I will give the control back.
I think it's, yeah, thanks, Max. I think it's a really good summary. We had a few glitches there, but yeah, I guess we can share all of this information. Also, we're going to post this, by the way, in the repo, so you guys can try it on your own as well. Everything within the system, except of course the ChatGPT, has been an open source component. And by the way, it doesn't have to require you to use Milvus or something. This is just one of the vector DBs. But yeah, we'll share this in the ChatDKG repo as an example of how you can utilize it with Langchain. I also think one note is appropriate here. We've been showing a little bit of JS, a little bit of Python. And that is because the DKG client currently is productive in the JavaScript version. The Python version is under works and should be available relatively soon. So you'll be able to do all of this just from Python if you're a Python type of a guy. Obviously, other clients also being something that will at some point be available in the future, as obviously as demand goes. So having that said, I'm just going to quickly go back to the presentation. I promise I won't go too long with the presentation. Just wanted to highlight one important point, which is that if you're interested in building in ChatDKG, again, there's a 1 million track token grant to build trusted AI based on knowledge assets. And you can find all of the information either by scanning this QR code or going to the chatdkg.ai website. Also, we'd really like to see you, if you're a builder, it's also basically one of the criteria is to join us in Discord. So you can scan this code, you can join us in Discord, or if you're don't like to scan things, you can type what you see on the screen here in this link. I suppose you cannot click, but we'll post this link in chat. I'm just joking. So long story short, we'd love to see you there. There's a pretty vibrant discussion, a lot of really cool people already in. And yeah, join us. That would be it will be great to continue chatting outside of these calls, which happen, by the way, generally on a bi-weekly basis. So yeah, I'm just going to finish by saying knowledge is power, knowledge shared is power multiplied. I hope you guys enjoyed what was shared today and that you can be helpful. From our side, this is again just an example. We'll provide all of this code on GitHub so you can play around with it and test it on your own. And yeah, do feel free to visit the OriginTrail website and ChatDKG websites to find out more info if you're interested, or reach out to us on Discord. So this would conclude basically the first 2 points of the introduction and the tutorial around ChatDKG. We're a little over an hour now, so we kind of have a 2-hour slot for this call, but we're basically gonna stop right here. And I'm gonna ask the folks who wanted to actually use the time to present today. So for what I know, there's 2 people. And they should, yeah, I see Mislav has raised a hand. So hello, Mislav, welcome, sir.
Hello. Hello, hi.
Everyone. There's Ivan. I guess you were first, so go ahead, Mislav. Can you give us a short intro about who you are and where you come from and what are you doing here?
Hello, everyone. I am Mislav. I'm from couple of companies at this point, but let's just say for the purposes of this call from Dev3. So I've been speaking with Branimir we've known each other for probably now like 6 or 7 years through blockchain and then Web3. And I've seen the progress that's being done on this ChatDKG, which I think is only one of the very interesting cases of like combating hallucinations from AI in the web world. I see a few different other interesting cases, but that's probably for a different time. You know what we do basically at our company is we develop developer-friendly SDKs for Web3 companies to enable Web2 developers to easily interact with blockchain. So some of our clients include Chainlink, Near. We have one client called Lucrify, which is a payments platform on blockchain. We have done some work for a couple of football federation loyalty token type things. So what our products essentially enables is the ability for any Web2 developer to do what like this demonstration just was. So, you know, so that you don't have to price the gas, so that you don't have to know, oh, is there an RPC node live? Oh, how long is the transaction taking? So basically our SDK exposes all of this through HTTP and calls to the JavaScript SDK, TypeScript SDK that we have, and the idea kind of arose naturally to present this solution to OriginTrail. into the community here to see if there is a possibility to build a wrapper around the DKG client JavaScript implementation to basically enable developers who are doing some AI stuff or some other stuff to build applications on knowledge graphs without being blockchain developers. So if I can share my screen, I can do a short, like 5-minute demo. I'll be very, very efficient.
Definitely. I guess you need permission for sharing the screen, right?
I think it's allowing me to share the screen.
Okay, cool. Go ahead, man. Awesome.
Yeah. I think if you can see the screen now.
Yeah. Yes. It works.
Okay, so basically, this what you're seeing right now. So I have this small presentation, but basically, I don't know if it's super great to do a presentation. I'm more of a hands-on type of person. But basically, the challenge here is that the DKG client is a JavaScript SDK or TypeScript SDK, which enables developers to integrate knowledge graphs. But it's still, as we saw from this presentation today, it still requires you to understand blockchain. You know, what's an RPC node? How do I price a transaction? What does it mean when a transaction is underpriced? The error today. So this is all very, very confusing and highly abstract for any AI developer or a front-end developer. And I've seen firsthand, I'm a developer, been a developer for the last 10-ish, 15 years, firsthand how developers really don't like to learn new technologies that they don't have to learn, specifically if it's a domain that they're not familiar with, such as blockchain. So if I'm an AI developer, I don't want to learn blockchain development. And basically, this is what we do. We build wrappers around SDKs that basically abstract away transaction signing, user interaction, all of these things, and enable those SDKs to be used by any developer. And also, it comes with this very nice dashboard that the developer can kind of click around and configure all blockchain stuff without being lost. So why, for the purpose of this this call is for AI developers to be able to develop extensions and plugins for AI tools that integrate knowledge graph, to enable AI backends to write updates into the knowledge graph. So if you're, having some new information, or if you're a big data company that wants to populate the knowledge graph, you should be able to do that without hiring a specialized blockchain developer. For Web 2 developers, it's to develop plugins and frameworks. Vladimir mentioned at some point that's like cool to have like this semantic analysis of web pages, like landing pages, apps, and all of these things to be able to be automatically fed into the knowledge graph. So it would be very easy to build like Angular or React plugins or WordPress plugins, Shopify plugins, whatever that would like do this job automatically and without popping up MetaMask all the time or something like that, by essentially doing it in the background. And for the users, at the end of the day, if you want to build some administration tools for knowledge graphs, like the ones you demonstrated today, it would be great if MetaMask didn't have to pop up, if I could log in with my email or my phone number or some other way. So what also with this SDK would come with built-in support for custodial wallet solutions and some hosted wallet solutions, of course, optional. If somebody wants to use an injected Web3 wallet, they would still be allowed to do it. And our previous work, as I mentioned, we have an ongoing relationship with Chainlink. For them, we are developing price feed mechanism wrappers for their SDKs, where we basically enable people to build front ends that consume Chainlink data without being blockchain developers, without knowing, how to do blockchain stuff. Lucrify is a crypto payrolls platform that was built entirely by Web 2 developers. So they have 0 Web 3 developers, and they built this payrolls platform through the use of our SDK. And then we built a low-code environment that enables Web 2 developers to create and maintain Web 3 apps on the Near blockchain. So this one is a bit more complex since they are not an EVM. So we had to do a lot of stuff from the beginning, but it's like a compatible SDK. Benefits, basically this would be just like a small wrapper around your DKG client. So you will like have an exposed variable on the Dev3 JavaScript object. All the same functions that you have, they would still be available, but just without anything beyond just the function. You wouldn't have to set the RPC node. You wouldn't have to set the wallet that is signing the transaction, all of these things, we would try as maximally as we can to abstract them away. You would get the dashboard basically where people could manage. So you see here third-party plugins, here Magic Link, RAM, but it could also be like OriginTrail, where it's a third-party plugin that we expose through our dashboard. And then people can put like the location of the node that's running the knowledge graph or other things, but through a visual interface instead of doing it through code. And then transaction processing. If people build front-end applications that are consuming the DKG client, any write transaction is going to be available basically through our transaction processing widget that will enable people to log in with a custodial wallet that will subsidize the gas, that will it can even subsidize the cost of the track tokens that need to be paid to store some information. So all of these things can be abstracted away from the user and make the experience of using DKG basically the same as using any Web 2 application, which I think is a very big aspect of adoption in the Web 3 world. And then just like icing on the top, you also get like full analytics, which is done through an integration with our new product called Polyflow, which is a Web3 analytics solution. But it's basically with the wrapper, it's a plug and play. You can say, okay, I want analytics also. And then you can track some wallet-based stuff, interactions with the blockchain in a more blockchain-friendly way. But let's say analytics here are not super important. They're just like a little bonus extra on top. How it usually works, basically, I have this small example here of this application. So basically, you go into your dashboard. So now I'm going to show interaction with smart contracts, but this is not going to be the case. Only this for the DKG. But let's say how it usually works. So you import a smart contract, you paste the address, and you give your smart contract an alias, something human readable that you can recognize it by. It appears in your My Contracts page. You go in, you see all the available functions on top of your contract, and for every function, you can create a transaction request, basically, which requests from the user to process this transaction. But also, this handles everything from like logging in the user. This one currently doesn't have a custodial wallet, but I'll show you soon the one that does. And it basically handles everything that a Web3 developer should handle usually, right? All of this, like connecting the wallet, executing the transaction, all of these things. So basically how it looks when it's fully integrated into an app, you have your app, you basically have this small SDK that you call Dev3 SDK, put your API key, put your project ID here, and then basically just say get contract by alias. You call it by alias, authorize it, present it. Basically present means like process the transaction. And that's it. Like basically there's no blockchain, anything, no RPC nodes, no nothing. And the app at the end looks like this. You basically click mint, then our widget shows up. So you can see this one has basically email login, but that's gonna take a while. So I'm just gonna connect with MetaMask. And it like confirm authorization. I can sign it, successful, and basically I get this was my like login to sign my address to prove that I'm the owner of the address. That's one feature. And then the second feature is to actually do a transaction. I get this very nice transaction preview screen, which tells me, you know, what exactly is going to happen. I can confirm it. Then I get like my MetaMask, and then I can process the transaction. But the core idea is that none of this is handled by the developer itself. So what we are proposing essentially is to add this as an extension to the DKG client TypeScript SDK. And one additional feature that gets added automatically is that you can also do this through an HTTP request. So it doesn't have to be through front end. So even people who are writing backend code can execute transactions on the blockchain. And we have like a private key holding environment where you inject your private key, where it's very secure. And then you have some certain rule management, who can process things, who can do certain stuff. And so, yeah, that would basically be the offering for DKG client in short.
Hey, Mislav, thanks, man. I guess the only person who raised a hand. I have a couple of questions, maybe just for clarification. One of them being, can you maybe explain a little bit more about the architecture? So let's say I'm an AI developer and I import your, that would be awesome if you can draw. That's amazing.
Yeah.
So we can understand because this let's say, pretty sure that at least part of the crew didn't understand 100%, like how does the wallet come into play? And from what I understand, all of the components are open source. So,
yes.
But yeah, can you tell us a little bit more about that?
Yeah, so basically everything that we do has been open source since forever. So you can access it here. We even don't retain the exclusive rights to like commercial usage of the code. Like somebody else is allowed to fork it and then deploy it. Basically, so we're trying to adhere as much as possible to the principles of blockchain, like openness and open source stuff. Yeah, as far as the architecture itself goes, basically it's reasonably simple. So you have this Dev3 backend. So here, so you have the Dev3 backend. Now, so this can be in two ways. So it can be either self-hosted, or you can have it managed by us. So this is obviously a commercial choice by any company. So basically, the SDK will do something like this. It will create transaction request, and basically the backend will then send the transaction info, like the fully populated transaction, back to the SDK. And then the SDK has a choice. It will either go like to the custodial wallet signer, or it will go to like Web3 signer like MetaMask. But like say MetaMask or whatever, it can decide. The front end, the SDK decides based on like your settings how it works. But there is also a second option, that you create a transaction request for the Dev3 backend, and then the backend itself deploys it to the secure signer, which is like your environment where you can sign transactions on your own backend, which has certain security properties which are good. And then basically either one of these three, depending on your configuration, will process the transaction and deploy it on blockchain. And then basically the backend will whatever this is, the backend will basically listen to this transaction, and if when the transaction is complete, backend says okay, blockchain says complete, and then the backend tells the SDK that it's complete, or it triggers a webhook for the backend applications, and basically that's it. So like that's how the architecture works in the background. So as I said, you can either use our managed solution, then we charge a certain fee for it, like a monthly software as a service fee, or you can use a self-hosted instance, which is just a Docker container that you deploy, and then you put inside the SDK. There's an optional parameter. Basically, the optional parameter is like, which is like the location of your backend, right? So the location where the SDK is actually triggering these requests.
Cool. Thanks, man. That's the questions I had. Anybody else have any questions, feedback for Mislav? Feel free to raise your hand or type or whatever. Tomasz, you are talking, but you're not heard, or at least I don't hear you.
I don't hear you,
Tomasz. This is a buggy day. Your microphone is buggy.
I don't know. I guess so. Can you hear me now?
Yeah, it works now. Go.
All right, cool. Yeah, and I just wanted to say it was a good demo. Thanks. I mean, there's some intricacies, I guess, that we could kind of work through. But yeah, from the first look, I think that having something like that would support the publishing and the creators of knowledge assets towards the DKG, and having that complexity subtracted would be very aligned. I think that even like you referenced the previous demo that we saw of knowledge assets and the Langchain and kind of LLM giving that trusted application components, having something like that could be even more like a bigger catalyst to go beyond some of the stuff that you have to do right now. So I think just by that simple reference, it seems that there's value to it. So yeah, appreciate you taking the time out to come and showcase this.
Thank you. Appreciate the good feedback.
All right, there's 3 questions in the QA. I'm just gonna assume the role of moderator here, I guess. First one is Mr. Amos Thomas ask, your private key is not exposed via the managed version of this setup. I suppose no, but I guess Mislav, you're the best person to answer this.
Yeah, so basically your private key always lives in the secure signer. So this is so the backend does not have your private key, right? So it's a separate component. Now you can decide on the level of security for the secure signer, right? So the signer basically it's a Linux machine that you have the credentials to. So basically, sorry, the managed version. I apologize. Yeah, so for the secure signer stuff, even for the managed version, we would recommend that you run the signer on your own infrastructure. So we would run the backend for you, but then the key itself and the signer should be on your own infrastructure, because we really have no way of preventing us from knowing the private key if we're signing your transactions. But that's the idea behind the signer being a separate piece of code that okay, like we handle, because the signer is a very, very simple application. It's trivially simple. So yeah, that's basically how it works.
But the way I understand it is also if you want complete, to be completely oblivious, and let's say you trust Dev3 to manage the key for you, you could do that, but you can also do all of the things in between, right? So you can have MetaMask, you can have custodial wallet, and you can host your signer, and you can host the backend. So the way I understood it is it's like Legos you can build together. So which seems pretty cool.
Yeah. So the idea is basically that we realize that there are everyone is comfortable with their own way of using Web3. Like I know people who would rather be found dead than use a custodial wallet solution. And then I know people who would rather be found dead than install a MetaMask extension, right? So I think good adoption in Web3 implies that the solution caters to all of them. So there's no reason for it to be like just for the one or for the other. Everything is basically, as you said, so it can be managed by us or it can be hosted by yourself. All the code is fully open source, so it can be audited by anyone, for potential security errors. And yeah, so we try to adhere to certain. But if we're but at the end, like I really want to be transparent. If we are hosting your signer, we have your key. So that's so you have a point of trust with us that we are actually we have your key and we can like sign malicious transactions if we wanted to.
Yeah, that makes complete sense. For in the interest of time, I'm just going to go ahead for the next question. It says, what kind of analytics are provided? Is the dashboard geared towards knowledge asset producers and node operators, or mainly asset publishers? Okay, so from what I understand, you can definitely give us a bit more on the analytics, but I guess the point here being is that it's more, like I said, it was more oriented towards the SDK and making it easy to create knowledge assets. But yeah, I mean, go ahead. Sorry, I don't want to answer.
So the idea is if you build out your front end, like you're building some front end application that consumes the knowledge graph or that that interacts with the knowledge graph in some way, at that point, like if you put Google Analytics on it, you wouldn't get super useful information. You could get like, oh, the number of page visitors, etc., all of these things. But we also have this separate product that we're building, which are going to get merged into a single product very, very soon, which is the analytics solution. So basically you just click, I want analytics, and then it will tell you like how many unique wallets have interacted with your front end DKG application, how many wallets, total transactions that were done, like what blockchains are people interacting with? Is it the parachain or the other blockchains that you are deployed to? Are they using MetaMask? Are they actually using the custodial wallet solution so that you can like optimize the user experience? Also, you can run like marketing campaigns and then see the performance of those marketing campaigns on wallets connected, transactions executed, all of those things. You can enter every campaign and then like find out more. And also like you get this cross-chain transaction tracker. So all the blockchains that you are interacting with, so which in case of DKG can be multiple blockchains, you have all the transactions in one place. You don't have to go through 3 different and this includes any parachain. So we support like literally any parachain that could ever exist, that's CVM, because we don't index the blockchain. We capture the transactions when they are traveling to the RPC node. So we just like extract the information like that. And the third part, maybe a bit less sexy, but also very useful, is customer support. So like if people are interacting with your DKG application, and they are not Web3 people, they really don't understand how blockchain works. Oftentimes they will have certain errors. You know, the transaction won't go through, they won't have enough gas on their wallet or whatever. You know, there's a billion things that people get wrong with interacting with blockchain. So you can like find all the sessions that have errors, and you can go into the session and you can see what the error was that your user had. And then you can send this to your developers or your customer support people to basically diagnose errors much more quickly. So our tooling is like 99% for front ends. So we don't really, you know, with the nodes and all of these things, that's not really our territory. But like executing, processing transactions and front ends, that's where we would see our added value from integrating our product.
Yeah, I think there's an opportunity, I guess, to leverage this also, because as we look at the OriginTrail's kind of ecosystem, and the creation of knowledge assets, the way that even the decentralized knowledge graph network is designed, is to really have this inherent horizontal scaling kind of available. So in a way, those that would be kind of on the front end side, being the knowledge asset creators, are or can also or should be also those that are or can be the runners of the infrastructure as well, because that helps them as to kind of participate in the network, and also by doing so have the track to finance the future knowledge asset publishing. So their incentives to kind of assume those roles are very much there, because they have through the node a gateway towards the DKG, like Max was showcasing, and at the same time they can also be an active participant. So in my mind, we have an equation equal sign between the knowledge asset publishers and then the kind of those that will be potentially also running the infrastructure, especially if those are more kind of like those heavy users, you know, like you
Yes.
are speaking about having DKG applications. So if someone is like a heavy load user who is banging out a lot of knowledge assets, for them it makes a lot of sense also to participate in that. And I don't see it as a big extension to what you're showcasing, that to kind of support that, and that makes a hell of a lot of sense. So that said, there is probably a separate discussion to be had in terms of just tailoring some of the stuff that could be there to support those functionalities. But I think it's one-to-one there. We could have a lot of value in the ecosystem by having that.
I'd love to participate. I've been following the work that you've been doing for the past, what was it, from the token sale, 5-6 years. So I think you're one of the few projects that survived through all the difficult stuff. So would be great to see, how we can help with the adoption and with specifically with developer adoption. So this is the point of these tools, very plain and simple, is to increase developer adoption so that they build more apps, which in turn, at the end of the day, generate more users. So that was the core idea behind Dev3 and behind all of these tools.
And could you? Yeah. Okay. Cool. Let's leave maybe now.
Yeah. Maybe I'm hogging some time for.
I think the discussion is amazing, and there's a couple of more questions, I guess. But in the interest of time, because we have 20 more minutes, I suggest we leave those for the end, because we have Ivan also with us who wanted to do a similar type of presentation. So I'd say thanks, Mislav. This looks really interesting, and thanks for joining again. Ivan, if you're ready and willing. Oh yeah, well, thanks again, man. Looking forward to chatting more. Ivan, take away the stage, man.
Yeah, so hi guys, I'm Ivan. I also know Branimir for quite some time. So I'll just start sharing screen and talking a little bit about what we are currently building and how we kind of can join together in a similar mission to fight misinformation. So what call writing actually is, I can maybe just go through a quick demo. So what call writing currently is a simple tool that helps you share, comment, and collaborate with content you find online. So we are helping customers from research and development, consulting, and content marketing to do collaborative online research. And it looks something like this. So you have this extension that shows you kind of a highlights structured around one kind of research topic, and those highlights are kind of locatable on different websites or different PDFs, and you can easily add additional highlights just by pressing enter and locating that highlight afterwards. So, and then of course comes collaboration. So you can write some comments, tag your colleagues, leave additional tags, etc. So you can then have searchable information and organize your online research. And after that, everything is collected inside a dashboard that is, again, searchable, has all the history, etc. And I won't talk anymore about collab writing right now. So what the idea kind of is, and what our biggest mission with collab writing is to fight kind of a misinformation, and how we see misinformation at this stage. So we see it as a, I have two examples. On the right hand, you have like Andrew Tate, everyone, journalists are constantly pushing him about what he said, but he just removed it from the website, and it was never recorded, never validated, and no one knows that actually was there before. And on the other hand, you have even bigger companies like McKinsey. So what the link here is a Google search that you can search, and you have like dozens of blogs that are highlighting this information that comes from McKinsey, and only website that doesn't show you this 9.3 hours per week statistic is McKinsey itself. So at this moment, this becomes a misinformation, because at some point probably McKinsey had that statistic on their website, but now it's not searchable, and you cannot link to it in the future to show that actually that statistic came from them. And now when you know about misinformation, when we see it, and a little bit of collab writing, we can talk a little bit about where we see fit between collab writing and OriginTrail. So what we want to do is to create those information, those highlights that people go around the web and collect, we want to make them verifiable. So next time that someone goes to a particular website and finds some information on that website and they collect them, they can see that data is actually verified, and that in some cases multiple people or multiple organizations has collected that verifiable information for the future. So they can reference that data in their reports, in their research papers, or in their news, or any kind of research they are doing. To do something like this, we need kind of two different actors to verify a certain information, because we are not dealing only with nodes that one particular person can create. So we are not dealing about information that I, as Ivan, can say something and then validate it and put it to blockchain. So everyone else can go back to blockchain and verify that I just said it. But we are dealing with information that someone else wrote somewhere, and then there are people who see that information and then want to add it to their particular knowledge and verify it for the future use. So because of that, there need to be two kind of actors in this part of the solution. So someone that collects the information, for example, journalist visiting some website, collects the information from that website, and then they can sign that information and push it to the validator, and the validator should be someone else who then validates the source of that information. In this case, that would be a truth chain, so something that we plan on open sourcing and developing. So kind of a web scraper in the beginning that scrapes that information and verifies that that information actually is present online, signs it again, and then push it to DKG. So we have one knowledge asset that is verifiable, verified from both one particular journalist, from validator that is kind of a validator, right? And then it's pushed to the blockchain. And in the future, we want to, of course, enable multiple different collectors to verify that information. So if you have piece of information from a particular website that is collected by multiple journalists and is verifiable by 50 journalists, it most likely has happened and no one else has modified that information. So what we intend on building is something we currently call truth chain, but it's not. We can change in the future. So first of all, it's a backend code that needs to act as validator. So you have client applications that sign particular snippet, send it to truth chain. Truth chain tries to fetch that information again, signs again, and then push it to DKG. And after that, when it's on DKG, it's verifiable. Besides that, we do everything in Java. Truth chain would be most likely in Java. A lot of enterprise systems are in Java. So as Brana said, the DKG client currently is available in JavaScript and it's coming to Python. We would be more than happy to help into building Java DKG client. And for the future, we can think about developing validators on client SDK for validators, as well as MetaMask Snap. I haven't really explored a lot about MetaMask Snap, but at this point, it sounds like we can do similar thing with their extensions, so we can create really open source, community-driven misinformation, misinformation machine that can help people just collect data, verify data, and then we can fight misinformation all together. And basically, pretty quick, that's it.
Awesome stuff. Thanks, Ivan. I guess I have a question or two, but I'm going to let others speak because I spoke for more than an hour. So it's only polite to let others ask. Any other questions, comments from anybody?
Yeah, I can go then. I think it's a very exciting prospect. I kind of was driving as I was surfing the web or whatever over the course of the last few months. There was numerous times that I had kind of like the impulse to just create knowledge assets from like a tab Chrome thing, and then I would then be able to expose that to some further kind of process, whether that's validation for like you described it, or whether that's more even to have it connected with an AI tool to just to browse it very easily, to have it like, and you know, like you also highlighted just that collaborating is having others complete that knowledge base of what you're kind of creating together. I know that would be, yeah, it was something else. I know also mentioned, and Brian, it was like collaborating is kind of in that direction, and seeing it right now, I think that's it would be, yeah, a very useful thing to see, and again, really driving also the bootstrap knowledge that is available in the DKG, because kind of those network effects can be that auxiliary help also with the validation of the truthfulness as well, because we can rely more on that social graph building out as well. So the more kind of it grows, and the easier we make it to do, the better kind of bottom lines we'll be able to draw from it. So yeah, I think it's I find it relevant. It's definitely in the space that could be valuable for the ecosystem, as well as kind of fits the mold of the ChatDKG. So I think those were my first thoughts for kind of like more content heavy feedback. I think we'll have time to have more direct discussions for that.
Yeah, that's kind of an idea with us as well. So since we started collaborating, we always had that idea that misinformation is something we want to fight. And we have a lot of journalists currently using collaborating as well. So, and besides, we have a lot of users just going over the internet and selecting highly important data. So nice. When I talked with Brana, that's what it told him. We had the same idea, kind of, but in that stage that we were thinking, we were the bottleneck, because we were the only one who is telling that information is valid or it's not valid. So this actually really makes sense with us as well, to create kind of a network effect, you already said. So when people land on the page, they see that there's verifiable data. They can learn a little about more about it, and then can just become the part of a community that actually help us to collect more and more data.
Makes ton of sense.
Totally. I see. No, that's a question from before. For Mislav, who just let me know he had to leave. Any other maybe questions for Ivan? Anybody, Ivan or Ivan, depending on how you want to pronounce it, where you come from. Back here in Serbia, we say Ivan. Anybody? Go ahead, man. Or not, looks like he froze. Do we still have you, Ivan, or are you gone? Okay, can you hear us?
I think I lost connection a little bit, and I have problems understanding you. So if there was a question, I haven't heard it.
Yeah, actually, we realized you were off, so the question was not around. I had a question. That's the last one for me for today. I'm curious. I suppose if you look from the perspective of the ChatDKG sections, I would put it in the, I could put it at least in two categories. One is the publishing, essentially creating of knowledge assets. The other one would be search. And you've shown us some search, but essentially the search that is available now, can you say a little bit more about it? How does that work?
About
the search feature that you have in Colab writing.
Search feature. So we currently have semantic search that is built on top of Azure Cognitive Search. So it's basically plug and play situation. They have API. It's kind of an index that you put data inside, and then you have a lot of features on top of that. But we were playing already with Langchain, because in near future we want to add additional features in searching PDFs and searching YouTube videos and podcasts. So not only to enable you to collect data, but like you currently have Control F on any web page, we want to create semantic Control F for YouTube's PDF, etc. So when you go to a particular PDF, you ask a question and you get that pop up, this snippet is important for this, do you want to collect it? Or you go to YouTube video, again, I want to get that statistic, you get pop up with transcription, you just add it to your topic, rich topic.
Very interesting. It's exciting to see that there's also kind of a not just plug and play solutions like the one we also showed one today, right? But also the capability of expanding this forward into, like you said, into a network effect. Because right now there's people are creating these isolated indexes, right, of semantic search like features. And one of the things that we're looking into with OriginTrail is how do we also connect those? So rather than just connecting knowledge assets, which is already like very powerful, we can also connect the indexes produced by these knowledge assets. And that's, again, a future thing, but coming up with a future version of OriginTrail, but would be likely the outcome of research and development done through the ChatDKG initiative. So it would be cool to share some more knowledge on that and experience, how does that work with Azure? And that would also be an interesting topic to see, like Langchain, Azure, OriginTrail together would be really cool to see a demo of that. Okay, I promised I won't be asking more questions. I guess we're almost at 2-hour mark. I suppose everybody has been sitting for 2 hours and maybe sort of low on energy. So again, I'd like to thank both of you, Ivan and Mislav, who I think left because he had to go. But it was really great seeing your presentation, guys. And by the way, anybody else who's on the call and who had an idea, you can totally let us know before the next call. Can jump in and you can present your idea the same way as today. We can do that in Discord as well. Feel free to reach out to anybody. And yeah, let's keep the discussion going, folks. We don't, we're going to be doing this very frequently, but Discord is there nonstop 24/7, right? So it will be awesome to have more chats there and continue this great energy today. Actually, I think it was a really awesome call today. Each call that comes after, it becomes more and more knowledge packed and exciting for me. So super thankful that you are all here. I'm closing with this. Anybody else have any final thoughts, questions, comments, feedback, whatever? That means we're at 1% battery energy. So let's recharge everybody. Thanks again for joining us for this great open office hours. We'll be sharing the presentations, and actually it would be cool if you guys want to share the presentations as well in the Discord. Feel free to do it or not. It's up to you, of course. We'll be sharing this in the code we had in the repo. And thanks again, everyone. Looking forward to chatting more. This was a really good session.
Thank you all.
Have a good weekend.
Take care.
Bye-bye.
Bye-bye.
Enjoy the weekend. Cheers.